Everybody, can you see my screen?
Yes.
Yeah. So once again, this is just the reminder of your midterm exam 1 to be held on Monday. Here today I am clearly mentioning the time frame 3 hours, as you can see, 9 a.m. to 12 p.m. until noon. So this means that, as I told you before, I have created a tabs called exams in the content page. I mean, where you see the class lecture video, at the bottom of that, you can see a new tab called exams. In that tab, I will be uploading that midterm exam on questions. So exactly at 9, it will be available. So then right after that, you can download or you can see by opening the file, and then you will start answering on your own, white blank pieces of paper. Of course, you must write down your name. And then once you are done, you made it a scan and make a single PDF file and then upload on the Dropbox. And I have already created a Dropbox that is called Midterm Exam 1. So that's all. Therefore, if you are done at 10, then okay, immediately upload. That's why I have allowed you 3 hours time frame. I think it will not take more than 1 hour if you know the answer, if you can solve it. But because internet issue and other reason, you may need some time to convert PDM or upload. That's why I have allowed you 3 hours. I think that will be fine. And then once again, as a syllabus, you will be looking from class lecture 2 through today. Today, this is the 14. Today is some practice problem. So that's all. And then you will be noticing there are 4 or 5 numerical problems, similar problems that you did in the homework or in the classes we are practicing, this type of 4 or 5 problems. So once again, if you know the answer, then it will not take more than 1 hour, I think. Okay, so with that, let's move. Today I have set up some simple problem for you. You all make a practice. You all really take your calculator, pen and paper, and you solve it, and you let me know the answer. So everybody see the first problem. For the following circuit, find out the capacitor voltage and inductor current at t equal to 0 minus, just before the switch is closed. Today we are practicing all 3 chapters. The first RLC transient, and then the second is sinusoidal AC circuit analysis, and then the last one is a power calculation that we did until last class. So it's a mixture. So therefore, there are 5, 6 question practice problem that you all do. So everybody understand the question. For this one, for this circuit, you find out the capacitor voltage. So you see 2 farad is the capacitor and 1 Henry is the inductor. And you see the switch on top, switch is getting closed at t equal to 0. This means before t equal to 0, at t equal to 0 minus, switch was open. So under that condition, you calculate and let me know what is the value of capacitor voltage and what is the flow of current through the inductor on Henry. So therefore everybody please do, and then you respond. You start practicing. Everybody, could you follow me what I said?
Yes, you want us to do this problem?
Yeah, please you do, and then you let me know the answer. You tell me. Everybody please try. This is practice. So this means this is just the initial value calculation. So you don't need to solve the long problem the way we did in the class or in the homework. Question is find out the initial condition at t equal to 0 minus, what is the capacitor voltage and what is the inductor current. So everybody, please try your best and you find out and tell me the result. So keep in mind that at t equal to 0 minus, that switch was open. As you can see on the top, switch was open at t equal to 0 minus. And then of course, the 12 volt, that is the DC voltage. This is not the AC because this is related to RLC transient. So tell me the answer for voltage and the current flowing through the 1 Henry. You even don't need the calculator. I mean, by mental math, you can do this one. I mean, just as a hint, you don't need even calculator. Just look the circuit and get the answer.
Is it 12 volts and 6 amps?
Current is right, but voltage is wrong. So
I have the answer.
do once again. Voltage answer is wrong. Current answer is right.
I have the answer.
What is your answer? Voltage.
Voltage across the capacitor is going to be 0 because at time equals 0. The
Exactly.
current
Yes.
going
Yes.
through the inductor is already 6.
Yeah. Yeah. So yeah, that's right. So therefore, voltage will be 0. So now everybody see voltage answer will be 0. And then the current answer is 6 ampere. So then everybody looks why? Because the switch is open. So therefore, this is your circuit. And so circuit has been at steady state, so before closing the switch. So meaning that because this is DC, so capacitor is open circuited. Capacitor is open and inductor is short circuited. And because capacitor is open, meaning that no current is flowing through the 4 ohm, right? Because capacitor has been open and then the switch has not been closed. Switch is also open. So no current is flowing through 4. So therefore all the current is flowing through the 1 Henry and that is the short circuit. So therefore ultimately current is 12 over 2. 12 over 2, so 6 ampere. And because you are measuring the voltage at this point across capacitor and no current is flowing through the 4, so ultimately you will be getting the 0 because your inductor is short circuited. So across a short, voltage value is 0. So therefore answer is 0 volt and 6 ampere. So if everybody is fine.
Yes.
Yes.
So therefore, if anybody, please don't hesitate. Please, hold me. Frankly, don't be hesitant. Don't be shy. If you still anybody has not clear, then please just stop me. I will explain again. These are the things that you must understand to solve the problem in the homework, in the exams, in any time, in your real life. many times, even in the job market, you might face this type of problem. So that day you have to do it correctly. So that therefore you write down the answer and then once again you look. So voltage is 0 volt and current is 6 ampere. Okay, then moving forward, the next problem. Everybody read this one. Question number 2. Consider the following RLC circuit, like 1 ohm, 1 Henry, 1 farad. So what type of response will it produce? So what type of response means, is it critical damp, is it over damped, or is it under damped? That is the meaning. So just you have to conclude that on what should be the response for this circuit.
Underdamped?
Sorry?
I thought it was underdamped.
Yeah, that's right. That's right. So everybody please make sure that he is right. Yeah, answer is right. This is underdamped. So how did you get that?
So the formula is R over 2L for alpha. So that would just be 1 over 2, which is 1/2. And then for W naught or omega naught, it is 1 over squared LC, which is just 1 over 1 in this case. So 1 is bigger than 1/2.
Yeah, so I mean, so although your answer is right, but the first thing, the alpha equation is wrong that you said. You said alpha is 1 over 2L, right?
I said R over 2L.
R over 2L. So because values are 1, that's why you got the half. But you look, this is the parallel circuit. So for the parallel circuit, there is another equation for alpha. So
1 over 2.
alpha
1 over
equal
2
to,
RC.
yeah, 1 over 2 RC, right. So therefore, because the all values are 1, that's why you will get the alpha value the same. But if you do alpha equal to R over 12, then that is the wrong. Do you understand?
Yeah, I just remembered it wrong. I forgot.
Yeah. I mean, answer will be the same because all values are 1, 1, 1. So answer is right, but the approach will be wrong if you write alpha equal to R over 12. So therefore, everybody, alpha equal to R over 12, that is applicable for series circuit. So in this case, alpha is 1 over 2 RC. And then also, as he said, find out the omega naught. And omega naught is 1 over root over LC.
Is omega not the same series and parallel?
Yes, right. Yeah. So therefore, omega naught is always the same for series and parallel, 1 over root over LC. But the alpha is different. And you said, and this type of problem, so I believe once you will be going senior year, I mean in the final year, final semester, then I believe you will take the FE exam. These are the type of the questions. You will be asked this type of simple questions, sometimes a bit complicated, but I have noticed some sample FE exams, mostly these types of questions are asked. And you might expect at least 8 to 10 problems from the circuit. I mean, consisting of DC and AC circuit. That's why I must recommend you all to understand these things. And then not only you will be doing well for this course, but also you can do well, very well in the FA exam. So, and then accordingly, like I discuss with you the numerical problems in the class, I set up homework so that you can get benefited not only from the class, not only your target is to do well and get good grade, but also your goal should be doing very well in the FE exam and in the job market. So is everybody fine with this one? Did you all get alpha 0.5? Equation alpha is 1 over 2 RC. So 0.5. And omega naught 1 over root over LC 1. So in this case, alpha is less than omega naught. Therefore, the response is underdamped. Answer would be the circuit will produce underdamped response. So is everybody able to figure it out?
Yes, sir.
Sir.
Or once again, like, please everybody feel free. I mean, don't hesitate anytime. So most welcome. If you have question, confusion, then please stop me. Then I will be holding. Please take your time, but try to understand. So I want to make sure that you all understand these things. And then if you really understand, then definitely you will do well in the exams, in the homework, and all you will be getting the good grade. That is like my goal. So, okay, the response is underdamped. That is the result. Now I am moving forward, the next slide. In this slide, there are two problems. Everybody see, question number 3, there is no circuit, just a statement. Given the sinusoid 5 sine of 4 pi t minus 60 degree, then calculates its amplitude, phase, angular frequency, period, and frequency. So everybody read number 3. That is your sinusoidal expression. Whatever it is, voltage and current, that does not matter. Expression is 5 sine, then in parentheses 4 pi t minus 60 degree. So therefore, which is the amplitude, which one is the phase, what is the amount of angular frequency, and what is the period? Period means time period, and what is the frequency for this waveform. So which one is the amplitude of this expression?
5.
5, right. So that is pretty straightforward. So everybody listen, like as someone said. So amplitude, or that is called the peak, or sometimes it is called the magnitude. So in the book or in literature or any other book, sometimes you will be finding it is called amplitude, that 5, sometimes peak value, sometimes magnitude. All are the same thing. Okay, that's right answer, the amplitude 5. What is the phase?
Is that minus 60?
Minus 60 degree, correct. So everybody look, the angle, this only like omega t minus 60 degree. So minus 60 degree is the phase, right? Sometimes it is simply called phase. Sometimes it is called phase angle. Sometimes you will say phase angle, but that is the same thing. What is the angular frequency?
4 pi.
Exactly. So omega, you see in the omega t, but instead of omega, it is written 4 pi. So that is the angular frequency, and that unit is in radian per second. Radian per second. So everybody see, angular frequency is just 4 pi, because that is the omega. And then now tell me the period and then the conventional frequency.
Period's t, and the frequency would be 1 over t.
Yeah, that is the, so what is the value of frequency and what is the value of time period t? What is the
Frequency
amount?
is 2 hertz. Period is half a second, maybe.
Exactly, correct, yes. So therefore frequency is 2 hertz, that's the right, and then time period is 0.5 or the half second. So everybody, could you follow? Therefore everybody look this on the 4 pi, that is the omega, like the angular frequency. So and then what is the omega? Omega equal to 2 pi f. Omega equal to 2 pi f. So therefore omega value is your 4 pi. So this means you are getting frequency, that omega over 2 pi. This means 4 pi over 2 pi is 2. So that's why 2 hertz. And then time period is like, as Priscilla said, t is 1 over f. So 1 over 2 means 0.5. So everybody, could you follow?
Yes.
Yes. I mean, these are just the pretty basic. Just I am making you alert and then more and more clear. We already covered this thing. So therefore, for everybody, I mean, this is the time to understand. I mean, as you go upward, as you move forward, the next chapter, and then you go the senior level, and then if you have some lacking in understanding these things, then you cannot do well. So you cannot go upward. Always and always, you have to look back and remember things. So therefore, this is the time, to understand things. And you know that this course 320 very, very vital. This is the gateway to many, many courses. So that's why accordingly I give you emphasize, and this is very important. I mean, keep in mind, you all must understand this one. Okay, so therefore everybody wrote down those things. So period is 0.5 second and frequency is 2 hertz. Now this is a problem. Now this time you will need calculator, definitely. See question number 4, find current I in the following circuit when VST, of course this is the AC signal, VST is 50 cosine of 200t volt. So based on that, this is 10 ohm, this is 5 millifarad, and this is 20 millihenry. So for this circuit, everybody please find out the current. So this time, definitely you will need the calculator. So once you will be done, then you can let me know the answer. Then I can understand that you did it correctly. So everybody, so at first what you would do? What will be the first approach?
I'd convert all the resistance, capacitance, and inductance to impedance.
Yeah,
the total
right.
impedance.
Into the phasor domain, right? Into the phasor domain, or the impedance from. That's right. Therefore, resistance is fine. You have to convert 5 millifarad and 20 millihenry into the impedance form or in the phasor form. That is the very first task. And also the voltage source, you have to express in the phasor form. So the VST is 50 cosine of 200t. So first write down that one and convert 5 millifarad and 20 millihenry into the respective impedance form.
Is the answer 4.79 cosine 200t minus 16.69?
Exactly, perfect. That's the right answer. Great. Exactly, that's the right answer. Everybody, current will be, amplitude is 4.79 cosine of 200t minus angle is 16.7 degree. That's the right answer. So everybody, please take your time and then do. So who said that one? Is it Brad? So who answered that question?
I thought it was Logan. I don't know.
What
Oh.
did you say the answer was?
So sorry, so who answered?
I was just asking what was the answer.
Oh, okay. So The answer was like 4.79. That is the amplitude, and then cosine of 200t, and that is possible, the minus 16.7 degree.
Oh, sweet. That's what I got.
Yeah, same. So I got.
Yeah, great. So everybody, first you have to find out the total impedance. So the total impedance is 10.44 angle 16.7 degree. So therefore, and then if I go detail, for 5 millifarad, you will be getting minus J1 ohm. And for 20 millihenry, you should get J4 ohm, J4. Did you all get those numbers?
Yes.
Yeah, great. Yeah. So therefore, I mean, this is pretty straightforward. That's the series circuit. So this one I have solved for you because a bit longer. Therefore, everybody please say, everybody please note. And then after the class, definitely I will upload this class lecture and you will be listening video. That is different. But I think I did not upload this class lecture. I uploaded class lecture 14. That is different thing. So I will replace with this one, because you will be making practice. So that's why ahead of time, I did not upload this one. But right after the class, I will be uploading this thing.
Is
So
this another example where if you left the answer like on your next to last line, the 4.7 angle negative 16.7, if you left it there, is that okay?
So you mean this line?
Yes,
This line?
correct.
Yeah, I mean, that is okay, but just keep in mind, because this was the originally the time domain circuit, you know. So I am asking find current I. So small I means that is in time domain. That is the meaning.
Okay.
And so that's why it is expected that he will be writing the last line as well. Yeah. I mean, everybody, could you follow me? I mean, what he is asking that whether I can leave the result here. I mean, of course, that is okay. But because the circuit originally was in time domain, voltage was in time domain, so it is the expectation that you will be leave the result in time domain as well. So that's why once you get this one, please write on more line. Yeah. So this is called the instantaneous or in the time domain. This is in the phase domain. But like if you can do up to this one, like almost you will get full credit. Maybe I'll be cutting only half credit or hardly one credit, but you will be getting the most credit if you can do until this one. Is everybody fine with this one?
Yes, sir.
Everybody, please look carefully component by component. Even I have shown you the calculation. Then I am here calculating the total impedance and then find out the current V over G. This is the result and just convert into time domain. So therefore, everybody, once again, later you will be looking all class lecture and of course this one as well. So I am moving forward. There are just, I think, 2 more problems. Then you are done for today. Everybody read this one. For the following circuit, find the Norton equivalent impedance and current at terminals AB. So for this circuit, find out what is the Norton equivalent impedance. This means the GN and the current IN at terminals AB. Find out that one. For this one as well, you might not need even the calculator. Yeah. I mean, you use calculator, but even you might do in mentally. You might not need the calculator. So again, as I told you, like exactly I have seen the very similar problem in the FE exam. And I mean, that will not take, for example, more than 3 minutes or more than 5 minutes. Just
Is it -8 over J2?
negative 8 over J2. No, 8 over J2. It will be plus 8 over J2. Then ultimately it will be minus
Yeah,
J4.
yeah, yes.
So ultimately result will be minus J4. So everybody, the Norton impedance will be minus J4. So therefore everybody, see, you want to find out the impedance by looking terminals A and B. So what you will be looking, if you keep your one eye, right eye here, and then your left eye here, and then if you look, you can see only this point and this point. So this means that you can see this component. This means that the remaining components will be in parallel to this one. That is the meaning, because you will be looking. So, but you see, this is the voltage source. So you have to make it short. So all voltage sources will be sorted. So this means that J4 will be in parallel with minus J2 because you are looking from here. So therefore this will be in parallel. Therefore what is the parallel? As I said that you don't need calculator. J4 multiplied by minus J2. And then in the denominator J4 minus J2. So therefore your denominator is getting J2. And in your numerator you see 8 and J square is minus 1. There is another minus. So your numerator is 8. So 8 over J2. And then take the J in the numerator. So ultimately minus J4. And now find out the current. Now find out the current. So two things. One is the equivalent, Norton equivalent impedance, that is minus J4 answered. And then next find out the current at the terminal A and B. So everybody please participate and then you try your best to understand.
The current, when you take it from point A and B, or the current through the inductor?
No, so what is the rule of the Norton? So you calculate the Norton equivalent impedance by viewing from these 2 points. And how to get the current? What is the rule of the Norton? So what you learned in DC circuit?
Well, you short, was it resistors, and you open, we short the source and you open the resistance, right?
No, so you have to make the short. I'm sorry, you have to make short these two terminals, these 2 points, A and B will be shorted. Only these things will be shorted. The other components will be as it is in the circuit. Because you want to find out the current here and then you made short. So you have to find out how much current is flowing through that shorted branch. I mean through the short circuit. So therefore your source will be as it is, other components will be as it is. Okay, can you remember that?
Right, but so if the current usually takes the path of least resistance. So if you short that,
Yeah.
it would be total current in the circuit, wouldn't it?
Yes, the total current will flow through the short circuit. Right. Yeah. Right.
Yeah, so
Now
we should just do the voltage divided by negative J2.
exactly. You got it. Yeah. So everybody see the Norton, to find out the current in the Norton theorem, you just need to make short, and then you have to find out current flowing through that short. So because you are making short, then ultimately J4 is getting shorted out. So you see, total current is coming from here through J2. So then no current will flow through J4. Therefore, all the current will go through the short because that has the least resistance or least impedance. So therefore, this means ultimately short circuit current will be this 6 at an angle 0 volt over minus J2, right? So that's why initially I said even you might not need the calculator here for this one. So then what should be the current value? Like 6 at an angle of 0 over minus J2.
The 3 at an angle of negative 90.
Is it negative 90 or positive 90?
I don't know.
Positive.
I got positive.
Positive 90, right, yes. Positive 90. Therefore, I think I have done it for you. Everybody see. You see, look, the current, IN, that voltage divided by minus J2. What is the meaning of minus J2? Minus J2 means 2 at an angle of minus 90, right? Minus J2 means. And then apply the phasor rule. 6 over 2 is 3. And then 0 minus 90. This angle will go in the numerator plus 90. So 3 at an angle of 90. This is the answer. And then GN calculation, I said minus J4. So everybody please look this one. This is the Norton impedance and Norton current. That's why I said that you might not need the calculator the way it is given. Is everybody fine? Does anybody have any confusion, question? So therefore, as I said, because for example, this is the Norton, then I might ask you about the Thevenin in the exam, for example, superposition, anything. Therefore, if anybody have forgot what is Thevenin, what is Norton, then please look even the DC circuit that you all did. Exactly same thing, same principle. At that time, you deal with mainly the voltage or current source and resistance only. And now you are dealing with all of these resistance, inductance, capacitance. So you have to do in the phasor domain or time domain. That is the difference only. But the rule, all principle, everything is the same. Therefore, once again and again, it's like this is your chance. And you know that after the circuit course, there is no other circuit course. I mean, during your undergrad study. So this is your like last course of the circuit. And there are some various things and all are useful. So everybody please try to understand. And then again, after the any time you are most welcome. If you have any question comment, please email me. Don't hesitate to contact me. So I'll be glad to answer your question anytime. Yeah. Sometimes I may be a little late in responding because like typically I remain very busy, but I will be responding you definitely. Whatever, in any homework, anywhere, if you have any question, comments, please don't hesitate. I mean, just expose yourself. If you be shy, if you don't ask me, then you cannot learn. You will be going upward by getting a grade, but you cannot learn. Always and always you will have lacking. So please feel free to ask me question. Okay, and then moving forward, yes. Okay, so this is the last question for today. So everybody please do. This is again the power calculation that we are doing in the last class. For a load VRMS 110 angle 85 degree volt and IRMS 0.4 angle 15 degree ampere. Then find the complex and apparent powers with the real and reactive powers and see the power factor and load impedance. Therefore here definitely you need the calculator. You cannot do mentally. So please use the calculator and find out the complex and apparent power, real reactive power, power factor, load impedance. Everything is being asked in this question. Please, you do.
Is the apparent just the product?
Apparent is just the magnitude of the complex power. So complex power definitely, you know, that is together with the angle, magnitude and both angle. Or in other words, it will have real and reactive component. But then apparent power is just the amplitude or magnitude of the complex power. And then, of course, you understand real power is that active power or average power, and reactive power is the reactive component. And then before we discussed power factor and then load impedance. First, you all try your best, and then I am showing you the solution. I have it in the next slide, but first you try. I am not displaying at the beginning. You do first. So therefore, complex power you can express in terms of magnitude and angle, and that format. In polar form, express complex power in polar form. Apparent power, as I told, just it will be a number. And then definitely real power will be a number. Reactive power is just a number. Power factor, it's a number. And load impedance, you can express either in polar format or in rectangular format. So load impedance, it will be magnitude together with angle. So that is polar form, or you can express in rectangular form. So at first, if you can calculate complex power, then that will help you to calculate apparent power, real reactive power. Everything will come from that on. Even the power factor, you can calculate all from the only complex power expression. Everything will come from there. So everybody, can you remember the equation for complex power? What is complex power from this VRMSI? What is the equation complex power?
Isn't it cosine omega t plus sine omega t?
No, why are you going in time domain? These are given in phase domain, right? Phasor domain. Look, VRMS, IRMS. These are given in already in phasor domain. So why are you going into time domain? You look how you can use equation by using these two. So
yeah, it's just power is equal to current times voltage.
yes, that's right. But for the complex power, you have to make on conjugate. So you remember, complex, everybody listen, complex power is VRMS multiplied by IRMS conjugate. Can you remember now? VRMS multiplied by IRMS conjugate. This means you have to use conjugate of IRMS. It is the multiplication, VRMS, IRMS, but for the complex power, IRMS will be conjugate format. This means you have the angle here plus, you have to use minus angle. IRMS conjugate. Everybody, could you follow me?
Yes.
Yeah. So therefore, first write down the equation like complex power equal to VRMS multiplied by IRMS conjugate. So complex conjugate means just you have to change the sign and then you calculate.
So I got 44 and an angle of negative 100 for complex.
I got
Negative
44 and 15.
Oh, wrong. Why are you making the wrong angle?
440.
44, that is right, magnitude, but angle? What is
I
the
might have just entered my calculator wrong. Let me try that again.
Yeah, please, angle is wrong. So for what you, magnitude is right, 44, but angle is wrong.
70.
Yes. You see,
What did they say the angle?
Are you subtracting the angle because of the conjugate?
Is it?
so you don't need to change the angle of V, like VRMS multiplied by IRMS conjugate. Only you have to conjugate the IRMS. So the angle of IRMS will be changed. I mean, it will be negative. Here it is plus, so you have to use minus.
So is it 70?
70, right?
Yes.
So therefore, probably you change the angle of both, right, at the beginning. Yeah. So therefore, only the I angle will be changed, IRMS angle. The equation is complex power, VRMS, multiplied by IRMS conjugate. It is not the conjugate of the combined thing, only conjugate of the current. Keep in mind. So therefore, this is 85 and this is minus 15. So once you are doing the phasor, the angle will be summed up. So 85 minus 15, 70 degree. That's right. So then what will be the apparent power from there?
44.
Only 44, right. So the definition of apparent power is the magnitude of complex power. So therefore you see in the complex power, if you see 44 angle 70, so just the magnitude portion, that is the apparent power. That is the answer. So therefore 44, and then unit is volt ampere. Both complex power and apparent power, unit is volt ampere. Just you write VA, volt ampere. Okay, and then now once you get the complex power, then you find out the real and reactive power. So the hint is that
A real 44 at 100?
no, completely wrong answer.
Like 15.0489 plus J 41.3465.
Yes, that is the rectangular format, complex. But what is the amount of real power and what is the amount of reactive power?
So is it just the real component of the complex power? Is that what you would? Okay.
Exactly.
So it should be like 15.04?
Yes, exactly. So 15.05 approximately watt, unit will be in watt, that is the real part. And then the imaginary part, as you said, 41.35, so that is the reactive power. And then the unit will be VAR, VAR. So everybody is fine. Now, like you have the complex power expression, 44 angle 70, then you just convert that on into rectangular format, the complex power. Then you will be getting like 15.05 plus J 41.35. That is the P plus JQ. So therefore real part is your real power, imaginary part is your reactive power. As I told you, the reactive power is kind of imaginary power. So therefore, answer is 41.35 watt and real power 15.05. And once you do, then the last two questions, find out the power factor. So again, if you just look the complex power result that you got answer, from there the power factor thing will come. And then the load impedance thing, you know the load impedance is voltage over current. So what you will be doing? Vrms over Irms. So Vrms over Irms. And then that is your load impedance result. So first let me know what is the power factor value. So what is power factor? Cosine of theta. Cosine theta, right? That is the power factor. Cosine theta. So therefore, which one is the theta? The
Was it
angle.
70?
Yes,
Is
yes, exactly 70. Right, right. The angle that you are getting in the complex part, then take cosine of that angle. So that is the definition of cosine theta.
This is 0.34202.
Exactly 0.342, right? Approximately, right? So therefore, everybody get it. So power factor cosine theta, but which on your theta? The complex power angle is the theta. If you remember that in the past two classes, always I drew the power triangle, phi, q, and then s, and then the angle theta. So this means the complex power has that is the power factor angle. So the power factor is cosine of that angle. This means cosine of 70 degree. So 0.342. And then finally get the load impedance, Vrms over Irms. And then just,
actually,
sorry?
that's the same as just doing the real over the apparent, right? For the
You can do that as well. So still you'll be getting the same result. You can do that. Real over apparent.
So are we getting 275 at 70 degrees?
Yeah. It's the impedance angle, 275 magnitude angle 70 degree, right? Exactly. And then either you can live in that format or you might express in rectangular format. I mean, either way it will work. So therefore everybody say, here is the solution, the full solution. You see, I just wrote Vrms, Irms, and then you see I am doing complex power raise. This is bold S. B Irms conjugate. You keep in mind this thing, Irms conjugate. So that's why it was minus sign here, sorry, plus sign here. I am using minus sign. If you see that it is minus sign here, then you have to use plus sign here because it is I conjugate. And then I got this one. This is apparent power. And then see, like how I did. 44 angle 70, I converted into rectangular form, which is like phi plus jq. So the phi is that this one, q is this one. Okay. And then power factor, cosine of directly that angle, complex power angle, directly. And also you will notice that lateral load impedance has also the same angle. So if you remember the previous two classes, I always told that like cosine of theta, if you think the impedance triangle like R, X, and G, that is also the same meaning. Therefore, if you make cosine of 70, then that is also the power factor. Therefore, what I am saying that if someone first calculate the load impedance, and if you see what is the angle with the J, and then take its cosine, and that is also the power factor, and you will be getting the same result because it is 70 here, or you look this angle. So which way you find convenient, either way you can do.
So the impedance triangle for this question would have an angle of 70 as well?
Yes.
Okay.
Yeah. And you see that is coming from load impedance, this Vrms over Irms. See my calculation. I just substitute 15 is going upward, I mean in the numerator. So 85 minus 15 is 70 degree. So this is the result, and I just converted into a rectangular format. I mean, you can live in this format. If you like, you can write on one line. That does not matter. So everybody, could you follow me? Is it fine?
Yeah, I had one more question about the power factor. You put lagging afterwards. Is that always the case, or is that?
No, no. Okay, very good question. So everybody see, that is very, very vital question. You will be looking this one. Is it plus j or you got the minus j? So in this case, I got the plus j. The accordingly reactive power is plus. Everybody see, if you get the minus here, so this means you have to write minus here. That minus sign is the indication that is the leading power. So therefore, I am answering your question. If you see that reactive power value is positive, then that is the lagging power. If you see the reactive power as negative, you got here, that will be the leading power factor. So accordingly, you will indicate leading or lagging. Do you get it? So the minus sign actually it will indicate that is the capacitive reactive power. The capacitive reactive power that can improve the power factor. You see, we last class we are doing one problem with the help of triangle by using trigonometry, power factor improvement from 0.5 to 0.9. That is actually the capacitive reactive power. Capacitor can provide the negative power to cancel the positive effect of the reactive power. So the plus sign, this indicates this is the reactive power, and that is coming from the inductor. And you remember in case of inductor, so other thing is that everybody, leading, lagging with respect to the current, whether current is leading or lagging. That is the meaning of leading, lagging. So therefore, because as I said, here it is plus sign, meaning that that is the inductive reactive power. Inductive effect is dominating. And what is the relationship of voltage and current in inductor? Current lags. Current lags voltage by 90 degrees. On the other hand, if it would the minus sign, as I said, that is the capacitive reactive power. What is the voltage and current relationship in case of capacitor? Current leads voltage by 90 degrees. So then you have to write leading. So therefore, everybody, you keep in mind, if you see the minus result here, like P minus JQ, that minus sign, you will immediately write that is the leading. If you plus, then it is the lagging. Is everybody fine?
Yes.
Yes.
Yeah, these are very, very vital, very important thing, leading, lagging. In the book or in any class, or if you go the higher studies, frequently leading, lagging, you will be looking the current. And that current, leading, lagging, it will be governed by the dominating component, whether it is inductive reactive power, is it plus or is it minus, it is the capacitive reactive power. That will govern you the conclusion, that will lead your conclusion, leading or lagging. And then if it is resistive circuit, then power factor is 1. So you don't need to mention leading or lagging if it is the power factor 1, meaning that that is the resistive circuit. So for the resistive circuit, you don't need to mention, and you will be getting a straightforward 1.0 on the power factor. Okay, so with that, so please you all be careful. Again, right now I am going to upload this class lecture, and then definitely like 30 minutes or 1 hour later, I will be uploading the video. Then you all please look and practice, then all homeworks and other solve problem. And these are the 3 chapters, and then you are ready to go with the exam. So I like that everybody do very, very well in the midterm exam 1. Everybody please try your best. Okay, so does anybody have any other question, comments, anything?
No, I only had one comment. My calculator like stopped working. That's why I was yelling random numbers.
Oh, no, you are fully fine. As I said, this is the practice class, and so it's the free-form discussion. So you are fully fine. I understand that sometimes calculator does not favor you. It does not help you. I know. Okay. Okay, so I am stop sharing.